What's going on, everybody? Thank you so much for checking in. In this video, we're going to go over the option Greeks, and we're going to do so using Robinhood. Now, Robinhood seems to be the most popular platform for beginner traders out there. However, if you use platforms like Thinkorswim or whatever platform you use to trade, as long as they offer options trading, then you're going to be able to find something called the Greeks. Now, the Greeks are a vital part of every option contract, and if you don't know how to read them, then you're kind of going into the option contract blindly. But don't worry, we're going to explain everything you need to know in this video. So we're going to go over delta, gamma, and theta. Vega and rho do have a meaning. However, your most focus should be around delta, gamma, and theta. Let's start with delta. What does delta mean? Delta gives you how much you're going to make per dollar that the stock goes up or down. The stock we're using in our example is SPY, and SPY is a very popular stock to trade when it comes to option contracts, which is why we're using it. So SPY right now is trading at 396.64. For the purposes of this example, we're going to round up to 397. Say you get into this contract and you pay $175 for it. The reason why that's $175, not $1.75, is because every option contract represents 100 shares, so you're always going to multiply by 100. So you're going to multiply this number by 100, which is going to be your buy-in price. So you pay $175 for this contract, and SPY is trading at $397. Now you're wondering, how much could I possibly make, or how much could I possibly lose if the stock goes up $1 or it goes down $1? So if SPY goes up by $1 and you're wondering how much you're going to make, you're going to look at delta. Delta is always a decimal point, and it's currently trading at 0.417. So what you're going to do, just like you multiplied the buy-in price by 100, you're going to multiply delta by 100 as well. So you're going to take 0.42 in this case, because it's a 7 here, so you're going to round to 0.42, and you're going to multiply that by 100, which will give you a total of $42. Now, give or take, this is not an exact number. That's about how much you would make if the stock goes up by $1. So you get into SPY at $175 for this contract. SPY goes up by $1. You're going to make $42 on the contract. So you would add 42 plus 175. That'll give you around $217. So remember what I told you, it's a give or take number. So if we look at the very next contract that's slightly more expensive, so we go from the 397 strike to the 398 strike, or the 396 strike, I'm sorry. So you go deeper in the money, you're going to see that the next available contract is trading right around 226. Now, why is that? Remember, we assumed that the stock's price here is 397 and it went up by $1, therefore you went into the money by $1, which means that your next contract's price is going to be right around 217. Lo and behold, the very next contract jumps from 175 to 226, which is roughly around the same price that delta gave us. Now that we know what delta is, we have to talk about gamma. Gamma is an assistant to delta. So delta gives you how much you're going to make on every dollar that the stock goes up or down. Gamma tells you how much you're going to make per second dollar that the stock goes up. So say SPY goes up by $2. In this case, you would make not 42, you would make 84. Why? Because it went up by $2. So you take 42 times 2. And then, because it went up $2, you're also going to add gamma. Gamma would be times 100. So this is 0.067. You're going to make that a 7. You're going to multiply by 100, which will give you $7. So if it goes up by $2, you're going to add about $7, and you're going to get a total of $91. So here in this case, if you got into SPY at 175 for this contract and it went up by $2, you're going to add $91 to it. And theoretically, you're going to make around 200, and your total contract price will come to 266. Now, as we said, it is a rough estimate multiplying by 100 because there's a lot of moving parts to option contracts. But if we go into the money $2 more, you're going to see that we're roughly close to what the contract would be. So here our calculations came out to be about 266, and we see that this contract is trading at 284, which is $2 more into the money. So you see, it's very simple. Now on the flip side, if the stock goes down by $1, you're going to be losing $41, and the same goes for the second dollar. So say you get into the contract and instead of going up $1 because you're on the call side, the stock goes down by $1. So it goes from 397 to 396. That means you're going to go up, and you're going to see that if we take 175 and subtract $41 and $42 because that's what delta is, it's going to give us around 133. Now lo and behold, what do you get? Right around 133. So fairly simple. All you're doing is multiplying delta by 100 and gamma by 100, delta being your main focus because that's going to be the highest value Greek, and then you're going to get how much you're going to make per dollar that the stock goes up or the stock goes down. Now, switching over to theta, theta is always a negative number. Theta is time decay. So it's going to represent how much you're going to lose per day that the stock is held. Now, theta, the closer you get to expiration, the higher theta is going to be. In this very example, we're only 2 days away from expiration. We could see that it expires in 2 days, which means theta is trading incredibly high. So if the stock opens tomorrow and it opens flat, this option contract is going to lose $65 of its value. And why is that? Because we're going to take 65 and we're going to multiply that by 100, which will give us, we're going to take 0.65 and we're going to multiply that by 100, which will give us $65. And if we subtract that from 175, we're going to get a total of $110. So just by holding this contract overnight, assuming that SPY opens flat, we're going to lose $65 to time decay. But if we push this out, say we go out 1 month and we look at the same contract, you're going to see that theta is a lot lower. It's going to be down to $16. So if you were to buy this contract, which would cost you a heck of a lot more, and you hold it for just 1 day, then you're going to see that you're only going to lose $16 for the 1 day that you held it. However, that contract will cost you a lot more because you have a lot more time till expiration. So pretty simple, right? Now, when we switch over to the put side, you're going to see that the option contract Greeks will be the same except delta is a negative number. Now, you'll still be making money on delta. It's only a negative number because you're on the put side. Now, not all option contracts are created equal. For this example, we're talking about SPY. However, if we talk about another option contract, let's pull up a company like APA. And this company is only $36. SPY is around $400. APA is only $36. So you're going to see that their option contracts are a little different. So if we look at the $36 strike example here, you're going to see that the Greeks are a little different. They're a little bit more attractive, in fact. So you can see that delta here is 48, but gamma is significantly higher. Why is that? Because the company here is only costing you $36. So for this stock to go up by $2, that is actually a very big effort, which is why it's so much more rewarding on the gamma side and not just the delta side. So when you're looking at the lower cost stocks and you pull up their option chain, you're going to often see that their gamma is also very high, not just their delta. On the SPY example, you only made about $55 for delta and gamma combined. Here, if you go up by $2, you're going to make about $75. Now, there are many moving parts to choosing an option contract, like knowing the bid, the ask, implied volatility, and much more. But for this example, we tried to keep it simple and we only focused on delta, gamma, and theta. I hope you guys found this video helpful. We tried to make it as simple as possible. Thank you so much for checking in. Don't forget to subscribe and like.